Hello and welcome to Life at PALS. This is our next video in the series where we go over life science questions to prepare you for the GED science test. And we will continue with question 44. If you haven't watched the other videos yet, I'd recommend you to start with the first one where we started the first questions of this series of life science questions. So let's get started. Salmonellosis is caused by rod-shaped bacteria called Salmonella that are present in moist, high-protein foods. These foods include meat, poultry, milk products, and egg products. Salmonella bacteria are often carried by flies or insects and household pests. Salmonella can usually be destroyed by cooking and by good hygiene. However, Salmonella can easily contaminate foods, even saved cooked foods that are not refrigerated. Food poisoning from Salmonella occurs most often during summer months and is often contracted at barbecues where food handling and hygiene may be careless. To reduce chances of Salmonella poisoning, refrigerate all perishable foods and make sure that people who handle food have clean hands. So here we get some information about Salmonella bacteria and where we can find them and how it can be prevented, the spread of Salmonella. Which of the following foods is least likely to carry the Salmonella bacteria? So in the text we get the information that protein-rich foods contain, or this is where Salmonella bacteria can be found usually, such as present in moist, high-protein foods, such as meat, poultry, milk products, and eggs. So that relates to the first question. Salted crackers, duck eggs, oysters, or cottage cheese. So cottage cheese is a milk product, so that's probably where we can find it, plus it's moist. Oysters are shellfish and quite moist as well, so likely to find Salmonella here too. Duck eggs are egg products, and salted crackers are none of these. They're mainly just carbohydrates, plus crackers are usually dry, so this is a food that is very unlikely to be contaminated by Salmonella. So A is the correct answer. During which month are the greatest number of cases of salmonellosis in the United States most likely to occur? So we got some information about that as well. Food poisoning for Salmonella occurs most often during summer months and is often contracted at barbecues for food handling. Okay, so during summer month, April, spring, July, summer, October, late summer, January, deep winter, so it's probably D. Oh, sorry, where it is most likely to occur. So that is during the summer, and that is July. So most likely to occur during July. Which of the following is least likely a source of Salmonella? So very common or very similar questions. The first one, a plate of raw hamburgers at a barbecue. Here we have raw meat, very likely to be a source of Salmonella. Picnic table containing scraps of food. Flies buzzing around garbage cans. Flies often carry Salmonella from one food to another. Garbage cans may contain old, unpreserved, not refrigerated food. At a campfire site, this is where we don't have any food. It doesn't say that there's food, so it's just the campfire site. So that is least likely to be a source of salmonella. Family at an afternoon barbecue wants to be protected against food poisoning. Which of the following is the least important action for the family to take? So anything that has nothing to do with hygiene, I would guess, and not eating any kind of foods that may contain salmonella. Toast the hamburger buns before making sandwiches. Thoroughly cook chicken and hamburger before serving. That is very important, so this is not least likely. Clean the surface of the grill before cooking. Hygiene sounds good to me. Clean the picnic table before setting utensils down. There might have been raw meat on the table before, or flies may have landed there before, so cleaning the table again is an important step for hygiene, keeping the surfaces clean. And toasting the hamburger buns before making sandwiches is not that important because, again, hamburger buns are not moist and they are not high protein foods, so it's unlikely to be a source of salmonella. So I would go for A in this case. Although it is a food, it is not a food where salmonella is likely found. Very similar again to the first question, the salted crackers. To prevent the possibility of food poisoning, which of the following should a shopper always check before buying a food item? The date on which it was produced, the list of ingredients it contains, the number of calories per serving, the date after which it should not be sold, and that's when it could be spoiled, so it is probably D. Which makes most sense, I guess. So let's look to the next questions. Refer to the following graph to answer question 49 and 50. Here we have a graph about annual malaria deaths per 10,000 population and years from 1900 to 1997. The graph represents the malaria death rate worldwide in the 20th century. The top line includes sub-Saharan Africa, whereas the bottom line excludes sub-Saharan Africa. So the top line, this one here, is worldwide, all countries, and the dotted line represents the malaria death rate worldwide without countries in sub-Saharan Africa and their population. Well, which of the following can be determined from the graph? The death rate in the 1990s was the lowest. In 1990s, death rate was the lowest. Not really, because you can see here it goes up again, including sub-Saharan Africa. And 97 looks a bit lower than 1990 here as well. So I guess we can exclude A. The sub-Saharan death rate increased after 1970, even as the death rate in the rest of the world decreased. That sounds very reasonable. After 1970, including sub-Saharan Africa, the death rate went up again, including sub-Saharan Africa as well. In sub-Saharan African countries, because we can see that it did continue to very slightly decline worldwide, excluding sub-Saharan Africa countries. So that is probably the correct answer. Let's have a look at C and D. The world death rate excluding sub-Saharan Africa, sub-Saharan death is greater than the death rate including it. No, including it, the death rate is greater than excluding it. There was a steep increase in the death rate between 1930 and 70. Between 1930 and 1970, there was a steep decline in death rate, not not an increase. So that means that B is definitely the correct answer. The highest number of deaths from malaria worldwide was recorded in the year 1900. Here the death rate is the highest on both graphs. Refer to the following diagram to answer question 51. Atoms, molecules, organelles, cells, tissues, organs, organ systems, and to the organism. We call this the levels of organization. What does this diagram describe? The functioning of organs in the human body? Nope. Levels of organization in a living organism? Yes. The process of evolution? Nope. How inherited traits are expressed? No. This is something that you need to know, so that this list here of steps from smallest, least complex to largest and most complex are called the levels of organization in a living organism. Atoms joining together, forming molecules that have a specific function or that have specific properties different from the atoms they're made of. Many different molecules joining together to form cell organelles, which have a specific function within the cell that the molecules on their own could not perform. Cells, a group of molecules and organelles and cell structures that perform specific functions that the individual parts on their own are not able to do. Tissues, a group of specialized similar cells joining together to perform a specific job in the organism. The cells on their own cannot do that. An organ is a group of different tissues working together to perform a specific function. Again, the tissues on their own cannot perform the function of the organ. Organ systems, a group of organs working together to perform a body function, and then we get to the final organism, the levels of organization. Immunity from a specific disease means that a person has the ability to resist that disease. 5 types of immunity are listed below. There is inherited immunity, immunity that is inherited, that is passed on from the parents and may be permanent. Naturally acquired active immunity, and often permanent immunity that occurs when a person's body naturally produces antibodies after being exposed to or infected by a disease. So if you have a disease and your immune system is fighting it off, then you are probably immune to that disease because your body has antibodies and memory cells that remember the pathogen, and if it comes again, your immune system is able to respond much faster and the pathogen will not make you sick again. So you have acquired active immunity naturally. Naturally acquired passive immunity is a bit more specific. It's an immunity lasting for 1 year or less that occurs in a fetus or a smaller infant because of antibodies that are passed down from the mother. This can as well, happens during breastfeeding from the breast milk. The baby receives some of the mother's antibodies and is therefore immune against certain pathogens that the mother is immune against. Since the antibodies are coming from the mother, they are not produced by the infant itself. The infant is only going to be immune against the pathogens as long as it has the antibodies in its own blood system, and after some time they will break down and then it is not immune anymore because its own immune system has not yet encountered these pathogens and it cannot make its own antibodies yet. Artificially acquired active immunity is a long-term immunity that occurs when a person produces antibodies after being injected with a vaccine containing dead or weakened disease-causing pathogens. Functions exactly the same way as naturally acquired active immunity, only that it is not caused by the actual pathogen but by a vaccine. Artificially acquired passive immunity is usually a short-term immunity that occurs when antibodies produced in an animal are injected into another person. And yeah, that gives a short-term immunity. Again, this is not long-lasting. When the antibodies are gone, then the immunity is gone as well. Studies show that children who were breastfed as babies are less likely to get certain diseases than children fed with baby formula. Research has shown that mother's milk provides antibodies that are not present in formula. What type of immunity is provided by mother's milk? Well, we already talked about that, and we said this is naturally acquired passive immunity. The answer is B. For protection against tetanus, an often fatal disease caused by bacteria, doctors recommend that children should be given a tetanus shot at about 2 months of age. The antibodies present in the tetanus shot are produced by horse. What type of immunity does tetanus provide? Again, in this case, antibodies are injected, so it's a form of passive immunity. It's not a vaccine. And since it comes from a horse, it is a form of artificial acquired passive immunity. Artificially acquired passive immunity. The natural concentration of antibodies in a person's bloodstream changes when the body is exposed at 2 different times to the same disease-causing organism. The primary immune response is often not sufficient to keep the person from getting the disease, but the secondary immune response may be sufficient. What type of immunity is this process? The natural concentration of antibodies in a person's bloodstream changes when the body is exposed at 2 different times to the same disease-causing organism. That sounds like a naturally acquired active immunity. Our immune system encounters a pathogen when we get infected by a disease, and the secondary immune response may be sufficient to become immune. So that is naturally acquired active immunity. So that's it for the screencast. We will continue in the next with another set of around 10 questions. Until then, have a great day, and I'll see you next time.